Hello, let's continue our Sudoku adventure with Above the Looking Glass by GDC. So we have normal 6x6 Sudoku rules, which means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. The way these work is there's a circle and then there's an arrow coming out of the circle. The digits on the arrow sum to the value in the circle. So if this was 2, 3, you do 2 plus 3, that's 5. We put a 5 in the circle. All right, and we also have this diagonal line here, which is telling us about a polarity mirror. So cells reflected across the marked diagonal have the same high-low polarity as each other. So for example, if row 4, column 2 is low, 1, 2, 3, then row 2, column 4 must also be low. And the same thing happens to high digits. So you can see, you can just go diagonally across the mirror. So here we're one away from where the mirror is, so we'd be another one away. So we just go here, and these two have to have the same low-high polarity. Or as I like to say, low-hiety. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so the thing is, with arrows like this, we can do 1, 2, 3. And that puts low in the circle. But the circles want to be high, but they don't have to be high, is kind of the thing. So I think there are probably some reflections that are important. So for example, here reflects to here. So these have the same polarity. But this can be high, right? This can be as high as 5. We could do 5, 1, and then 6. Now, okay, so, but what about this guy? So I'm going to just mark in green. These two have the same polarity. This one and this one have the same polarity. So I think this is kind of our start, because the purples have the same polarity and the greens have the same polarity. What is this saying? Well, in this here, we know that purple must be less than green because of this arrow, because this plus whatever this is equals green. So purple must be less than green. But over here, we have the opposite. Green must be less than purple. Now, green aren't the same digit. They're just the same polarity. And purple are the same polarity. And so that means they're all low. Because if they were all high... Or sorry, we can they both be high? They can both be high as well. Sorry. They're the same polarity as each other. Whatever polarity they are, they're the same polarity because this is less than this. So I can actually type some letters here. A is less than B, but then over here... B is less than A. So the only way that's going to happen is if they're equal. So they have to be the same polarity as each other. So they're either both low or both high. So I'm actually just going to use green. We're going to make them both green, and we're going to use that to represent that we have the green polarity here. Now, this goes to here. This goes to here. I'm not seeing other, like, obvious... See, I can't make this necessarily green. If these were both low, then this is definitely also low. It makes it green. If these were both high, then this actually has to be low. Oh, so this is always low. Oh, that's really interesting. So let me go over why. So if green is low, obviously if we're adding to a low digit, we can only do that with 2 low digits. In fact, we'd be doing 1 plus 2 is 3, which is possible. But that would make this low. The other option is these are both high. Now, if this is a high digit, like a 4 or higher, I can only add a 1 or a 2 to it. Because if I try to add 3 or higher, I end up with 7, and 7 isn't in the puzzle. And so this not only is this low, it's a 1 or a 2. And then that means this is also low. I'm going to use blue for low. Green is, I don't know what it is. It could be blue or it could be low or high, but I'm going to use blue for low. And then I'm going to use, in fact, I don't have to put 1, 2, 3 if it's unrestricted. I'm going to use orange for high. Kind of like a cool color and a hot color. Now this here has the same deal, right? If this was low, this is definitely... If this is low, this is definitely low. If this is high, this is also still definitely low, and it can't be a 3. So that's also 1, 2. And that's going to reflect right here. Putting a blue there. All right. That's some progress. Now... Is there an issue with green being blue? Not that I see. So the thing that I know about lows and highs is there's 3 of each. And so in every row, column, and box, I get exactly 3 lows and exactly 3 highs. But I don't see any particular restrictions on that yet. Oh, these two have the same parity as well as each other. And so we get the same thing, which is that this has to be low. So it doesn't tell us what parity these two are, but it does tell us that this is a low one too. If this is low, it must be 3, but that kind of works out. These two, I'll just call it purple. I don't... the problem is, like, I can't call it green because we don't know it's the same parity as these two. But we do know they're the same parity as each other. I guess we'll just remember that. Because I don't want to get confused and think, oh, purple's different than green. This is a little different. They reflect here. The problem is that we can repeat on here, and so that loosens up our restrictions a bit. Is there like an obvious... Oh, I see. This goes to here. Oh, of course. I forgot to mirror this one when I colored this blue. So this being blue means it must be a 2 or a 3. And then these definitely are blue. And they're from 1 or 2. We could do 1 plus 1 is 2, or we could do 1 plus 2 is 3. Those are our options. Oh, but this is a 1-2 pair in the box, so this has to be a 3. So these are 1-2 pairs then. This has to be a 3. We have a 1-2 pair here, so that's a 3. These are all orange because the box has all 3 of its lows. This doesn't reflect anywhere, but this reflects here, and this reflects here. Okay. Whatever these two are the opposite. We still don't know if green is... Oh, so now we know this doesn't add to 3, which means that these have to be orange, right? We know it doesn't, because 3 is used up in the column. So these have to be orange, which means these are orange. And so these are... The sum is 5 or 6, because we know that this is 4 or 5. Still don't know about this, as far as I can tell. We do need a 3 somewhere up here. Can we do 1 plus 2 is 3 here? I don't see why not. I'm going to subcolor the 1-2s. So I'm going to say this is the green 1-2. And so if it's a 1, then green is 1. If it's a 2, then green is 2. And so what we know is that this is not the green 1-2. It's the other one. We're going to call that purple. And now we know that these have to be different because they add to 3. So it's going to be a 1 plus 2 in some way. And then we know these are different because of the column. So we have quite a bit about the green 1-2. In fact, this has to be the green 1-2 right here as well. And then this has to be the green 1-2. We have a new blue. So this is a blue over here. We know it's not the green 1-2. It's also not 3, so it has to be the purple 1-2. So these two green 1-2s, these two green 1-2s look down, putting the green 1-2 right here. And that is a new blue. So that puts a blue up here. And then this is orange. Finish the box with an orange. That reflects here. Oh, okay, I didn't do this reflection correctly. We already knew that. How do we continue? I'm trying to think about this arrow. It's really the only arrow left. It's either that or there's Sudoku here. We need a 3 over here somewhere. Purple. Do we know more purple 1-2s? Yeah, okay. No, because we don't know if these are 1-2s. They could be 3. In fact, one of these is a 3. The other one's a purple 1-2. Okay, we do have 2 purple 1-2s looking up. Yeah, basically the purple 1-2 is somewhere here. If it was here, then this would be the 3, which seems reasonable. I can't, just because these are both the green one too, does that force them to be? No. So if green was 2, that would be interesting because it would force both of these to be 4 and these two to be 6. If these were both 1, then these could both be 4, making both of these 5, or these could both be 5, making both of these 6, or we could have a 4 or 5 pair, we could get a 5, 6 pair. So I don't really know. There's something about this cell here where it sees both of these that intrigues me, but I don't know what to do with it. Is 5 always used? No, because we can do 2. We can do 2, 4, 6. I don't know that I can prove it's not orange. At least not at the moment. If it was orange, then these would be the same as each other. Same digits. Okay, let's say these two were the same digit as each other. Then it would end up in one of these two. That seems okay. If these two are the same digit as each other, it would also end up in one of these two. Oh. No, I don't really see I don't really see anything from that. I thought maybe, oh, this row actually. Oh, yeah, this is just blue. Oh, much easier. I completely just missed this reflection and this row. I was so focused on those arrows. These two are orange. And then this reflects here as orange. So this is blue. And this has to be the 3. This is the purple 1, 2. So that places the 3 here, which is blue. And that does mean this is orange, which means these two are the same as each other, right? The reason I know that is whatever this is, it eliminates from both of these. Like if this is a 4, then these are both 5, 6. If this is a 5, these are both 4, 6, right? And they have to go in the same order because of the arrow. But I don't know if I need that. This is the purple 1, 2 for the column. This is the orange. I'm probably I keep missing the mirrors when I color. Can I color up here? I'm not sure, but I can subcolor the oranges now. But you know what? Instead of coloring, I'm just going to put some letters in here. So I'm going to call this the A, and we know here. Actually, let's start here. Let's call this the C. Whatever this is, we call it C. It goes here down here as well, and because both of these don't have C in them, they're the A and B, and we know that this is always less than this, and this is always less than this, making both of these A and both of these B. So now we have A, B, and C going on here. Can we keep going with A, B, and C is the question that I'm asking. We know this is an AB pair. I don't know that that helps. You know, this is a BC pair. So that means this is A. And this is B. Oh, and this B looks up. So this is C and this is B. So this is A, making that A, making this a B and this is an A. Meaning this isn't B, so that's not C. So this is our C. Okay, so now this cell here sees A, B, and C. So it can't be A, B, or C, meaning it has to be blue. And since it's blue in the column, it has to be the 3, and that makes this an orange. The less interesting thing to happen, but we do get a 3 in the corner celebrating, so there's that. This is a C. Oops, not 2, C. Oh, and we have all our blues for the row. So yeah, this is orange. Also, we knew that both of these were the same for a while now because of the parity mirror. So this is the purple 1, 2, and then this is B. And I think I have all of my highs labeled with A, B, and C. So now we know the kind of the order that A, B, and C go, which means we know what they are, right? A is less than B, and B is less than C. So A has to be 4. So all of my A's are 4s. All of my B's are 5s. All of my C's are 6s. And that means all my greens should hopefully be 1s. And all of my purples are 2s. And that makes this a 3 and this a 2, and we're done. Let's just make this 2 a purple. There we go. Cool, nice puzzle, GDC. Had to do polarity coloring and then subcoloring, which is always fun. But we got it done. All right. Well, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.